All right, section 6.6, we get into the rational zero theorem, which is the section where we kind of put everything together that we've been covering the past couple days. So the rational zero theorem says if a polynomial has integer coefficients, then every rational zero has the following form. It's going to be in the form of P over Q, where P is a factor of the constant term. And just a reminder that the constant term is the term with no variable. And the Q is the factor of the leading coefficient. Okay, so how we would do this is the P is the constant term, the P's are the factors of the constant term, and the Q's are the factors of the leading coefficient. So what we would do is we would list the factors of the P's. So the P's would be anything you can divide 12 by. So you can divide 12 by 1, by the way, 1 or negative 1. You can divide 12 by 2 or negative 2, 3 or negative 3, 4 or negative 4, 6 or negative 6, and 12 or negative 12. Those are all the numbers you can divide 12 by. And we pick 12 because 12 is the constant. The Q's are all the numbers you can divide the leading coefficient by. And the leading coefficient is 1, and the only thing we can divide the 1 by is 1. So our possible zeros are P over Q. So the first P is a 1, and the only Q is a 1. So the possible zeros are 1 over 1. The next P is 2, so it would be 2 over 1 because P is 2, Q is 1. We could also do 3 over 1, 4 over 1, 6 over 1, and 12 over 1. These are the possible zeros. You take every P and you make a fraction with the Q's. In this case, there's only one Q, it's 1. By the way, you could reduce this. I'm just going to show you. If I wanted to, instead of saying 1 over 1, you could just say 1. In 2 over 1, you could just write down 2. 4 over 1 is just 4. 6 over 1 is just 6. 12 over 1 is just 12. And 3 over 1 is just 3. So you don't have to say over 1. I'm just doing that to show you that the Q is 1, so P's over Q's would be all the P numbers over 1. Let's do number 2. Same process. To find the P's are any number you can divide 7 by. We can divide 7 by 1, and we can divide 7 by 7. The Q's are any number you can divide the leading coefficient by, and the leading coefficient's 2. We can divide 2 by 1, and we can divide 2 by 2. So P's over Q's would be the possible zeros. So our possible zeros, let's pair them up. The first P is 1. The first Q is 1, so it would be plus or minus 1 over 1. We'd also, by the way, let me change colors. So we're pairing these two up. And then we got to pair up the first P with the second Q. So it'd be 1 over 2. So 1 over 1 and 1 over 2. Then you take the second P value and pair it up with the first Q, which would be 7 over 1. And then we have 7 over 2. So we have 1 over 1, 1 over 2, 7 over 1, and 7 over 2 are the possible zeros. Okay, it doesn't mean that they're going to equal 0 when we do synthetic division. It means that they might equal 0. We're kind of limiting down to what could be a 0. So that's how you find the possible zeros. Now, if you look at the next example, it says, find the real zeros of the function. Okay, we want to find the real zeros of the function. We find the p's first. The p's are what can you divide 6 by? So 1, 2, 3, and 6. Those are the p's. The q's are what you can divide the leading coefficient by, and that's just 1, because the leading coefficient is 1. So if we do p over q, we would do 1 over 1, which is just 1. 2 over 1 is 2. 3 over 1 is 3. And 6 over 1 is 6. So all of the possible zeros, we have 1, negative 1, 2, negative 2, 3, negative 3, and 6, negative 6. So let's say we start with, let's try negative 1 first. So you would do negative 1 in the box, and we're going to do synthetic division. So 1, 4, 1, negative 6. And we can do each of these separately like this. You would bring down the 1. Negative 1 times 1 is negative 1. And then we add them up. 4 plus negative 1 is 3. Negative 1 times 3 is negative 3, and we add them up to get negative 2. Negative 1 times negative 2 is 2. Add them up. We don't get 0, so we know that that doesn't work. Okay, so negative 1 did not work. You can try positive 1 or positive 2 or negative 2. You pick one of these other ones. I'm going to try positive 1. And you will list out your coefficients again. Bring down the 1. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. 1 plus 5 is 6. 1 times 6 is 6. And 6 plus negative 6 is 0. So this one did work out. So what that means is we have a winner. One of the zeros is 1. So we put that in our box. That's one of the zeros. To find the other zeros, we could keep checking all of these to see which ones work, or we can write this out just the way we did with synthetic division. So x squared plus 5x plus 6, and we can factor. This is going to be the faster way. When you write this out, you get x times x and 3 times 2. So we wrote it out and we factored it. And the reason this works is because the inside gives us 3x, the outside gives us 2x. 3x and 2x adds up to 5x. So we know that we have the correct numbers. Once we factor this, now we want to find the zeros. So we set these equal to 0. So if you solve the first one, you would get x equals negative 3. So negative 3 is another 0. And you solve the second one, you would get x equals negative 2. So the zeros are 1, negative 3, and negative 2. And if you look at that, those are all up here too. Positive 1 will be here, negative 3, and negative 2. Those all are part of our possible zeros. So that's how we can use the possible zeros to find the real zeros. Okay, and off to the side, I'm going to show you kind of a shortcut way we could do this. And some of you may think this is easier, some may think it's harder. It saves you time and it saves you room. So what you could do is list your coefficients across the top. Okay, that would be these numbers right here. Instead of rewriting them all the time, you just put them across the top. You can list your possible zeros along the side. So that would be the numbers over here. Your possible zeros along the side. So now what you do is you don't show all the steps. So in your head, you would do, okay, you bring down the 1. Okay. 1 times negative 1 is negative 1. And in your head, you think, okay, what is 4 plus negative 1? You would get 3. -1 times 3 is -3. -3 plus 1 is -2. Again, you're doing this in your head. All right? -1 times -2 is 3. -6 plus 3 is -3. It did not give us a 0, so you would cross this out. So basically what we're doing is we're eliminating or getting rid of writing down this stuff. We're kind of doing the addition part in our head. If I do one more row like that, I would bring down the 1. Okay, and it'd be 1 times 1 is 1. 1 plus 4 is 5. 1 times 5 is 5. 5 plus 1 is 6. 1 times 6 is 6. 6 plus -6 is 0. Once you get a 0, you know that you're going to use this to factor and find your other zeros. So it's the same thing, but a different way to set it up. Okay, we have one more problem to go. So example 2, the p's are anything that you can divide 12 by. So you can divide 12 by 1, 2, 3, 4, 6, and 12. That's where the p's come from. The q's come from the leading coefficient, and the only thing you can divide 1 by is 1. So if we list out the possible zeros, possible zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So we list them all out. And now we could do it the way I just showed you, where you draw the coefficients across the top and the possible zeros on the left side. Or you can do it the old way where you actually write all the workout. They're both correct. One just saves you time. So if we do it the way I just showed you, would kind of set it up like this. You put all of these numbers across the top. 1, 4, -3, -12. And you put all the possible zeros across the side. So we got 1, -1, 2, -2, 3, -3. And we can try these numbers out first to see if they give us a 0. So again, what we do is bring down your leading coefficient. And now it's 1 times 1 is 1. And 1 plus 4 is 5. 1 times 5 is 5. 5 plus -3 is 2. 1 times 2 is 2. 2 plus -12 is -10. This did not give us a 0, so we cross it out and go to the next one. Bring down the 1. -1 times 1 is -1. -1 plus 4 is 3. -1 times 3 is -3. -3 plus -3 is -6. -1 times -6 is 6. -6 plus -12 is -18. Sorry, it was +6. I screwed it up. +6 plus -12 is -6. It did not give us 0, so we crossed that out. Try the next row. Bring down your 1. 2 times 1 is 2. 2 plus 4 is 6. 2 times 6 is 12. 12 plus -3 is 9. 2 times 9 is 18. 18 plus -12 is 6. That did not give us a 0. Bring down the 1. -1 times 2 is -2. -2 plus 4 is 2. -2 times 2 is -4. -4 plus -3 is -7. -2 times -7 is 14. 14 plus -12 is 2. That also did not give us a 0, so we got to keep going. Bring down the 1. 3 times 1 is 3. 3 plus 4 is 7. 3 times 7 is 21. 21 plus -3 is 18. 3 times 18 is 54. 54 plus -12 is not going to give us a 0, so we keep going. Bring down the 1. -3 times 1 is -3. -3 plus 4 is 1. -3 times 1 is -3. -3 plus -3 is -6. And negative 3 times negative 6 is 18. 18 plus negative 12 is 6. So we still don't have a 0. So let's keep going. Let's add in the 4 and the negative 4. Bring down the 1. 4 times 1 is 4. 4 plus 4 is 8. 4 times 8 is 32. 32 plus negative 3 is 29. Okay, and we know that that's not going to give us a 0. Try negative 4. Bring down the 1. Negative 4 times 1 is negative 4. Negative 4 plus 4 is 0. Negative 4 times 0 is 0. 0 plus negative 3 is negative 3. Negative 4 times negative 3 is 12. And 12 plus negative 12 is 0. That's what we wanted right there. So we're going to use these numbers and write out x squared plus 0x minus 3. So one of our zeros is negative 4. We take this equation to find the other zeros. So we have x squared minus 3 equals 0. If we solve this, and by the way, I'm getting ahead of myself, we don't need to put down the 0x, so over here I didn't put it down. So we add 3 to get x squared equals 3. And then we take the square root to get x equals plus or minus square root of 3. So the other zeros are square root of 3 and negative square root of 3. And that would be our answer.